Good evening. Abhimanyu Arora. Hello.
Yes, sir.
Okay, we will start the class after 5 minutes. Maybe um another students.
In the meantime, sir, would it be possible to just give a small recap of the topics covered in the last Friday's class? Just a small overview so that because I was in the train at that time, I was
Okay,
going
okay,
home. So if you can
okay,
just tell, I can mark those topics in the book.
okay. I will just restart. So in the previous class, different techniques in remote sensing are covered, like that. What is the aerial photography and what is the thermal remote sensing and what is the optical remote sensing and hyperspectral. So generally, the satellite move in the different path and row. So this is the path and this is the row. So suppose this is the one tile of the satellite image, which is acquired. Then it is 191. It is the path of this satellite image, and one that is the 51 is the row. So path and row are the identity and the ID of this satellite image. Based on this row and path, we can download different satellite images. So this is covered in the last class. Then different aerial photographs and photographies are used for the remote sensing technology. So generally aerial photographs are high resolution, high pixel resolution satellite image, and minimum 10 to 15 centimeter of spatial resolutions, and they have the special characters that it has some 60% overlap in the satellite image, that is the 60%, and 20% in the side lab and 60% in the front. So this is the characteristic of aerial photography. Then scale. So scale is more important in the aerial photograph and other satellite image also. So it is the ratio of image distance to ground distance. So if 5 centimeter is the image distance, then 5 kilometer is the ground distance. Then the scale ratio is 5 centimeter divided by 5 kilometers. So maybe it is 10,000 or 20,000. 1 is to 10,000 or 20,000. So this type of scales are mapping. Then relief displacement. Suppose one height object is there, then if we measure this features, then there is a difference in the information of the height from top and bottom level. So this difference is calculated in the images. Then this is called as the relief displacement. So displacement due to the elevation or due to the relief information of the object is called relief displacement. So sometimes there is a hill or some buildings are there. So due to the elevated area, some relief informations are uh, calculated. Then photogrammetry measurement, so measurement of different geometry of the pictures with the help of some measurement. Then it is called the photogrammetric measurement. For 3D, especially 3D calculations, photogrammetries are used. Then the different photographic methods are used previously in plane table photogrammetry, then analog photogrammetry, then analytical photogrammetry, then it transport to digital photogrammetry, then angle of optical axis. So there are vertical photographs of satellite image, then low oblique photograph of different aerial photograph, then high oblique. So based on the angle of incident of the sensor, so different photographs are created. So this is one of the picture of the vertical, then low oblique, then horizontal. So these are the examples. Then this is the application of aerial photography of agree. This is the application. So a lot of application like survey mapping, urban planning, agriculture, environmental monitoring. So these are the applications. Then different bands are there. So in multispectral sensor, blue, green, red, infrared, photo infrared. So these are like B1, B2, B3, B4, B5. So every bands have different wavelength. So if every wavelength has different characteristic, so if features are behaving differently with a different wavelength band of the different color. So this is one of the graph which shows the different uh, shifting of the graph with the water, vegetation, and soil in different wavelength and different bands. So this is the picture when blue band is there, then green band is there, then infrared. So in the infrared bands, the water features are clearly visible. So most of the time we are use uh, infrared band for demarcation of water body and land features boundary and mangrove area. Then some multispectral and thermal remote sensing. So this is all the multispectral. Then thermal remote sensing generally the related to the heat and the heat information that is emitted from the Earth surface. So this is the blue, green, red. This is a true color satellite image. Then there is the false color satellite image. That is green channel given to blue, then red channel given to green, then near infrared given to red. Then color is synthesized. Then this is the result of the false color composite. So in this false color, the green vegetations are clearly visible in the red color. So in the false color, maximum we are using for the vegetation identification and especially for mangrove identification. So these are the some single band features of visible near infrared, short wave infrared, then thermal infrared. Then different index are calculated using different bands like NDVI, SEVI, EVI. So especially NDVI is calculated for vegetation health assessment, like near infrared minus red by near infrared plus red. So calculating these bands and formula, we create a image that gives the value of different features from -1 to 1. So if the healthy vegetation is there, then it shows 8 to 9 or 8 to 10. This sorry, 0.8 to 1 is the value for the healthy vegetation, and 0.6 to 0.7 is the moderate healthy vegetation, and 0.2 to 0.4 is the degraded vegetation areas. So very vegetation degradation area and healthy vegetations are demarcated with the help of NDVI calculations. Likewise, SEVI and soil adjusted vegetation index and enhanced vegetation index and NDVI built up index, all a lot of index are there. So based on the bands, we use different index. So this is the example. So dead plant shows -1 to 0 in the NDVI, then 0 to 0.3 is unhealthy, 0.3 to 0.6 is moderate, then 0.6 to 0.31 that is healthy vegetations. So this is the NDVI calculation of different time. So it gradually decrease the NDVI value as the increase of the urbanizations and the green vegetation are degraded with the construction of different buildings and different concrete structures. Then thermal is basically for urban heat island mapping and forest fire mode mapping and soil moisture estimation. So basically for surface temperature analysis, we use the thermal remote sensing. So Landsat TIR, Astor, MODIS, and VIR. They are the sensors which are used for the thermal remote sensing. So this is the thermal remote sensing image, and this is the optical visible satellite image. So this is the same area image, and it looks like this. And temperature difference are given in the different color. And this is the water body. So water body shows very less thermal conductivity. So that's this is the difference in the thermal and visible satellite image. Then different scatterings are there, and most of the time thermal remote sensing use the emission, not the all the other scattering features. Only emission from the earth surface that is detected by the sensor. Then this emission are collected, and based on this the features are detected in the image. Then different absorption of different gaseous material in different wavelength is given. And then the hyperspectral remote sensing. So mostly hyperspectral remote sensing, more than 100 bands are there as compared to the optical remote sensing. So mostly 10 to 20 bands are there in the visible range or optical remote sensing, but high spectral bands are there in the optical hyperspectral remote sensing. So some of the examples are Everest from the NASA, high C data, Hyperion. These are the example of the hyperspectral remote sensing. So this is the image of the hyperspectral satellite image. So it generally gives the different graphs of specific minerals or specific metals or specific features. So this graph are unique. So in all these hyperspectral image, the graph is nearly equal. So we synchronize this data with the field spectroradiometer. Then we calculate the estimate the presence of different minerals or other features. So basically, for vegetation index or vegetation species mapping or different forest species mapping or for different mineral identifications. So these data are used because it had lot of bands and the band widths are very narrow. So each narrow bands can detect different features and different characteristic of the metal. So that's why it is very much helpful for identification of different category of mineral or different species in the forest area. So this is the true color satellite image in which the sand area is totally white, but in the hyperspectral image, this area is different color by different category because of the different chemical compositions of this sand shows in this area. So this is the hyperspectral and multispectral. So it has only 10 to 12, but it is in more than 100 images there. Then generally used in mining mapping, which is already covered. Then forestry and military surveillance also, and coastal ocean studies for algae, seagrass, coral reefs. So algae, coral reefs, seagrass. So basically these are all related to the vegetations. And this is one of the example of the average data, which is very high resolution data. So there are 224 spectral bands are there, and average NG, that is 4 to 5 meter resolution. Then average classic is 18 to 20 meter spatial resolution, and it's a very costly satellite image. Sorry, it is airborne image. Then it some of the sites like Himalaya glacier mapping, coastal wetland like Chilika and Sundarban already covered, and some other part of the US are also covered. So it is not globally coverage, but some specific eco-sensitive areas are covered, and the study is ongoing. So these are the basic things about the thermal remote sensing, hyperspectral remote sensing, and optical remote sensing. So different satellite image, different bands are used for different remote sensing technology, and their applications are also different. And specifically, hyperspectral is nowadays very useful for different applications due to the lot of bands presence in the frequency. Okay, then we'll start the next class. Today's class. This is the previous class slides are there.
Thank you, sir,
So
for the.
now the screen is visible now.
Yes, sir. Yes, sir.
Okay. So this is now the today's topic is the introduction to microwave remote sensing. So previously we discussed about the hyperspectral remote sensing, then uh, thermal remote sensing and optical remote sensing. So this technology are based on the reflectance and emissivity and emission of the electromagnetic radiations. But microwave
I think,
remote sensing,
excuse me, sir, can Mr. PVSA mute because I think there is noise.
yes,
Mr. PVSA, can you mute because there is this uh, noise.
just a second. Okay, tell me,
Can Mr. PVSA be muted?
Ken.
Mr. PVSA participant can be muted because I think there is noise from his side.
Okay, okay, okay. I think it is muted.
Thank you, sir.
Kindly mute all uh, participants so that it will be audible to all of you. Just check and it is muted or not. Just check it. Okay. So now it is audible. Hello.
Yes, sir. Thank you.
Okay. So the microwave remote sensing technology is very different from other technology. Like it is very highly technological aspect. There is so it is not related to some reflectance value or the reflectance. So mostly we collect the satellite image based on the reflectance from the Earth's surface. So now the microwave remote sensing, it is working in the microwave region. It is a high wavelength and it some of the active microwave remote sensing have their uh, own source of emission EMR rays are there. So in different angles. So we'll discuss the different characteristic of microwave remote sensing, how this work, and different applications. Then so microwave remote sensing is a way of studying the earth using microwave energy and a type of invisible light with long wavelengths and instead of normal visible lights. So special things about the microwave remote sensing is it can see through clouds, fog, and even light mm, in rain or in dark or night. So it works day and night because it does not depend on sunlight. So other optical remote sensing or thermal remote sensing have some issue with the clouds. So most of the um, EMR radiations does not penetrating through the cloud due to the uh, low wavelength due to the high wavelength of this microwave remote sensing technology. So it penetrates through the clouds, fog, and also it is working in the day and night. So in active mode like radar, that is radio detecting and ranging, the sensors send out microwaves and measures what bounce back. So it just uh, send out the microwave and then the reflected bounce of the microwave data can be detected by the sensor, and based on this reflected reflect back of this data, say create a image. So this image give the different information of different uh, Earth surface features. So these are the technology. So in passive mode, it just measures the natural microwave energy from the Earth. So when the microwave energy emitted from the Earth's surface, then this reflected this emitted microwave waves are collected from the sensor, and that after that the images are created. So most of the thing we use the active microwave remote sensing sensors due to the day night uh, operation. Then microwave remote sensing assume microwave radiations uses wavelength from 1 mm to 1 meter. This is the wavelength and frequency range 0.3 to 300 gigahertz. So most of the time we use in the optical range, that is zero point 0.4 to 0.9 micrometer, but it is 1 mm to 1 meter. So its wavelength is very high. That's why it's painted through the cloud. And spectrum region is lies in the longer wavelength, and some of the bands are there. So like blue, green, red, infrared bands. So in the microwave range, there are the bands like L, S, C, X, E, KU band, K band, and K band. So you must have heard about the KU and K band. So these are used for the telecommunications in the telecommunication satellites, like distant antennas and different TV. Some of the KU bands and K bands are used, and other weather forecasting satellites data bands are also there. So microwave radiometers is one of the instrument that used to measure microwave radiation emitted or deflected by various objects in the Earth's surface or atmosphere or ocean. So this radiometer give the different information about the Earth's surface. So there's several properties of the microwave radiations, like brightness, emissivity, and other characteristics. So first is the brightness. So the brightness refers to the intensity of the microwave radiation emitted and reflected. And brightness usually measured in unit of power per unit area. So this is the solid angle, that is omega. So A is the area, and a radiance, that is R is equal to P by A into omega. So this is the formula of the radiance. So based on this, brightness values are calculated. So in microwave remote sensing also we use these methods. Then emissivity is, it is a measure of how well an object emits the radiation at specific microwave frequency. So different features are there in the Earth's surface, like vegetations and water bodies and rock and other features are there. So different features have different emissivity in microwave wavelength. So this emissive uh, informations are gathered in the digital form, then it transport to the image form. So this is one of the microwave lens surface emissivity soil texture image of the global level. So based on the microwave remote sensing. Then the polarization. So one of the important factor of the micro remote sensing is the polarization. So what is the polarization? So it is the property of the electromagnetic radiation that describe the orientation of the electric field vectors. So generally electromagnetic radiation EMR is constitute of the electric field, magnetic field, and the directions. So they are in 90-degree to each other. So this is the first image that uh, uh, the picture depict the electric field, magnetic field. The electric field is in red color. Then blue is the magnetic field, and the direction of the wave movement is in the black way wrong. So this way the EMR moves. So in the microwave region, suppose any radiation is penetrating through the earth, then the reflection, then the reflected radiations and incident radiation have different wavelength. So there are two type of um, waves are there. There is a vertical to vertical, then horizontal. So there are possibilities of suppose incoming of horizontal wave, then outgoing of reflected back of the radiations in the vertical. So in this type, if the sensor is uh, called as the HB polarizations. So incoming is in horizontal way, then reflected back or back scatter is in vertical. So likewise BH, that is incoming of in vertical, then back scatter in horizontal. So first letter is the incident, then back scatter is the second letter. Then VV polarizations incoming and back scatter in both in the vertical to vertical. Then HH polarization, that is horizontal incoming, then reflect back in horizontal. So there are four way of incident and reflected of electromagnetic radiations in the microwave remote sensing. That is HP, VH, VV, and HH. So these four type of polarization have different applications. So for agriculture, so different polarization is used for vegetation and for earthquake estimations. So different polarizations are different characteristics. So this is the reason for this. There are four polarizations are used in microwave remote sensing.
Sir, you mentioned the word Dex cutter. So, how
Yes.
do you spell that? You mentioned
Uh,
the term Dex cutter.
huh.
How do you spell that?
Suppose this is a suppose a microwave sensor is transmitting one rays for its own sensor, then it reflect back from a surface of different features. Then this reflected back radiation is not same to the incident of this radiation. So if the incident wave is in the horizontal way, then the reflected of this radiation in the vertical way. So that's why this type of complete form is called HB polarization. So incident and reflected back. So reflected, it's not the reflected term is used in the microwave remote sensing because it is back scatter, because it is specially uh, created EMR which will be backscatter from particular object to know the different information, to gather the information of this of these features with specific angle. So it is not vertically capture this data for a specific angle. It just incident in the particular area, then it is backscatter. So this backscatter may be vertical or horizontal uh, is- or VV or vertical to vertical. So two-way, then this vertical two-way, then in this wave is backscatter, and two-way this incident can be uh, go through it. That is horizontal or vertical. So for
And
height,
sir, one more question.
yes.
Sorry, I interrupted you.
Okay, tell me.
Sir, for example, HV and VH, how can they be different? It's only a matter of relative distance. I mean, HV and VH would be conceptually, I think, the same because it's only a matter of relatively turning something at 90 degrees, I think. What is
Yes,
what is vertical for you might be horizontal for me. So HV for you might be VH for me. So in some sense, it would be same, no?
Yes, but when a particular sensor is sending this EMR, so it is particularly intention to send this data in horizontal, and so I think that for me, I think it is horizontal. If I take this in different angle, then it is look like vertical. Okay. So how can we decide it is vertical or horizontal? So it is sensor based. So they have the informations. So which is horizontal and which is vertical polarization. So all this information are collected with the sensor. So based on this sensor data, we know that is a horizontal and vertical, or it is a VH polarizations. So different polarization data are collected in different layers or different file. Okay, so it is not understood.
Yes,
Hello.
sir. Thank
Okay,
you.
we'll give other details about the polarizations if times permits. So it is a small side slides related to SB and VH. So maybe it is confusing. So we'll elaborate later. Okay, a lot of class are there. Then these are the picture of the frequency, incident angle, and then polarizations. This is the one of the polarization. This is the horizontal polarization. This is the vertical polarization, and the different geometry of the trees and different dielectric constants. So dielectric constants is basically the then the object that affect the amount of microwave radiation that is absorbed or emitted by the object. So based on the different chemical compositions and different materials present in the earth surface of different features, so different features behaves a different way with the electromagnetic radiation or the microwave radiations. Based on the chemical compositions, some can absorb more and some can reflect more. So this is the dielectric constants of the object. So based on the dielectric constants, we can estimate, we can create the image. So we analyze all these informations, then we just verify with the ground truth. Then we can mapping all this data that this is the sand area or this is the vegetation areas. So different features have different dielectric constant values. So based on these different features are behaving in a different way in the image. Then this is the different bandwidth of the microwave remote sensing. So VHF bands generally used for FM radio television. Then USB bands basically used for the television broadcast and astronomy. Then L band is basically used for military telemetry, GPS, air traffic control. Then S band is weather radar, surface radar. Then C band, there is long distance radio telecommunications. And then X band, there is satellite communication radar. KU band is also satellite communications. K band, that is radar satellite, and K band. So different bands have different applications based on their wavelengths. So it is from 1 mm to 10 meter of the wavelength of this microwave remote sensing sensors. Then there are two type of microwave remote sensing, that is passive microwave remote sensing, and one is passive, and that is another is active remote sensing. So in the passive, generally some emitted electromagnetic radiations are received by the Earth's surface to the sensors. Then this scatter EMR are recorded by the sensor. Then that creates some image. So this is called passive remote sensing. So it has no own source of EMR. It is based on the sunlight and other emissive power of the Earth's surface. So that's why it is called as passive remote sensing, microwave remote sensing. Then, so it simply measures the electromagnetic energy that is radiated back from a target or area. Common example is microwave radiometer. So this is one of the example of microwave radiometer. So generally, this microwave radiometer is measure the intensity of electromagnetic radiation in the microwave and radio frequency range. Uh, Operates the detecting measure the power of radiations. Then it has some image radiometer, so it creates some image and some of the data is non-imaging radiometers are there. Some of the examples are of the imaging radiometers are advanced microwave scanning radiometers (AMSR), and some of the non-imaging radiometers are sensor microwave imager (SSMI) and microwave humidity sounder (MHS). So these are the example of imaging and non-imaging radiometers. Then active remote sensing. So in the active microwave sensor use their own microwave radiation source to illuminate the target and can be classified into two types, that is imaging and non-imaging. So radar, that is radio detecting and imaging, is the one of the example which creates some image based on the electromagnetic radiations and radar waves. So there are three type of sensors are there, that is strip map mode, scan SAR mode, and spotlight mode imaging. So generally there is a scan SAR mode, there is a strip mode, so there is a spotlight mode. So generally microwave sensor or microwave satellite image generally create the image with some distance, that is the distance that is 20 degree. So it backscatter the image, so it is not vertically created some image like the other satellite image. So it just backscatter, just radiate this energy, incident this energy, then it is backscatter and is received by this sensor. So this sensor, after this receiving, this image are created. So these are the three-way imaging system. One is strip map mode. In this strip map mode, the antenna remains fixed in a specific direction. So this is the image. And when the beam continuously scan the Earth's surface at a constant rate, so it is fixed particular area. So in this way, that scan all the area of the Earth's surface. Then scan SAR mode. In this mode, it have five subway path is there. So there are the five path. Then in this path is just scan the area, then create some image. Then spotlight mode, that is the resolution can be enhanced by increasing the angular coverage. So if there is a need of high resolution, then the angular coverage it changes from far to near area, so that the resolution is very high. And if need the larger coverage, then the angular variation is increases. That is the called spotlight mode. So there are the three type of active remote sensing sensors are there. Then this is the passive microwave sensing example, and this is the active remote sensing. And there are some of the example. Lot of L bands, C band, and X band, and K bands are there, where we use different applications. Then, like in the optical and thermal remote sensing, there is a spatial resolution. So there is a pixel dimension. So minimum pixel dimension is calculated. Then this each of the pixel length is called the spatial resolution. So for microwave remote sensing, there is not specific pixel. So it is a backscatter technology. It is not a pixel-based technology. So there are two type of resolutions are there. That is range resolution and azimuth resolutions. So generally, range resolution is refers to the system's ability to differentiate closely spaced object. So how, if the two features are there in the Earth surface, how closely this EMR is backscatter, then this closeness is called as the uh, range resolution. If the two objects are far away and this way this backscatter is receive this data, then it is a low resolution. So if the closeness is very narrow, then this is the high resolution. So it represents the minimum detectable distance between two separate entities, relies on the pulse duration and receive bandwidth. So based on the distance and pulse durations and receive bandwidth. So there are the three factors are very responsible for the range resolution. Suppose this is one of the example. Suppose it transmit the wave in the which is the distance is L, and there are A and B. These are the two different features, and they have the slanting distance is D. Then it backscatter. So this is the backscatter, and this is also backscatter. So within this distance is very low, then it is a high resolution, and the distance is very wide, then it is low resolution. So basically it how this sensor closely detected and reflected back this data in a different gap. It is the gap of the two features. So this is also one of the example, the slant range resolutions. Then azimuth resolution, it is a micro sensing system ability to distinguish closely spaced object in the perpendicular flight direction. So it is a minimum angular separation that can be detected as separate entities. So this is different angles are there. So
Sir, your
the
screen has gone.
screen is
Screen
not
is not visible.
visible.
Yeah, now it is visible.
Okay, okay. So this is the azimuth and this is the far range. So if we change the angle, then the coverage is different, and the large area coverage is covered by the sensor. Then the resolution is decreases as the coverage is high. Then the resolution decreases. If the coverage is very low and it is near the nadir point or near the perpendicular to the surface or nearer to the surface, then the resolution is very high as there is the um, least distance between the sensor and the earth surface. So based on this, the different angular changes, and in the different angles different resolutions are also changes. So based on the angle based information, then azimuth resolution is calculated, and based on the two backscatter minimum difference backscatter technology, then that is the range resolutions. So it is not in the spatial resolution is different in the microwave remote sensing technology, because it is the backscatter technology in the microwave remote sensing. Then different non-imaging radars are there like altimeters, scatterometers. One of the example is CSET, SAS is example of scatterometers, and different different scatterings are there in the micro remote sensing pictures like specular. So if the sensor transmits some energy, then it's reflected back like this, that is the specular. And if it is diffuse in different areas, then it is a diffuse scattering. And if it is reflected back in different angle, then it is corner scattering. And if the incident rays in the trees or any big areas, then the scattering is in the large way in a volumetric manner. So this scattering is called volumetric scattering. So most of the features volumetric scattering are found in the forest areas and in different vegetation areas due to the presence of the different canopy cover of the trees. Then active sensor data processing softwares are there. So like RGS and other QGIS, this sensor have a different softwares or different analysis softwares are there. As these satellites have the larger um, data memory because it is a backscatter informations are there. Suppose particular 1 kilometer to 1 kilometer in optical sensor, it is 5 GB. Then for this micro remote sensing satellite image, that is 10 times more or 5 times more, that is 50 GB or 25 GB. So most of the time the data are 1 TB and 500 GB data are there. So it is very volumetric in nature, and this is in a lot of softwares like MATLAB is used popular, is a popular software. Then Python also use some programming libraries are there. Then NV software is very much used the micro applications. Then SARScape that is also used. Then Sentinel application platform SNAP that is developed by the European Space Agency, and this is of free of cost. And NV is commercial software. Then Gamma remote sensing software is also providing this. Then PCI geomatics also there, and one two softwares are also provided by the SAC Ahmedabad. That is from ISRO. This is also a open source software. So these are the softwares we can use the use of the microwave remote sensing satellites. So this is the infrared photograph of the image, and this is the microwave remote sensing satellite. Different C band in HB polarizations, green band is HB and L band is HH. So different polarization techniques are used. So these are the one of the depth of radar. So generally, why use the microwave remote sensing? So in the microwave sensing, we can measure the height information of the trees, and it can penetrate through the canopy cover of the trees. That's why the growth of the tree and growth of the crop is also estimated with the help of the micro remote sensing. And building heights and earthquake measurements and landsliding and all a lot of applications are there. Then flood area mapping, as it is cloud free data, so in the monsoon season also we can calculate the flood affected areas with the help of microwave remote sensing. So suppose there are the three different bands like X, L, and C bands. So suppose there is the red band, that is X, and it is wavelength is 3 centimeter. So it cannot penetrating through the trees areas. So it is penetrating upper area of the different trees or forest. So it gather information of the canopy cover of the area. And second, there is the green wavelength, that is L band, which is 24 centimeter. So it can penetrate through the canopy cover and just touch to the ground. So it can detect the height informations and other informations. And blue band, that is also C band, that is 6 centimeter wavelength. So it is also penetrating through the surface of the canopy cover of the trees. So based on the wavelength and different bands, so different bands have different characteristics. So longer the wavelength, then more penetrating capability of the sensor, particular wavelength. So based on these penetrating capabilities, we can calculate the depth of the waters and height of the trees, and different elevation areas also. That's why you generally use this microwave remote sensing. So it is costly nowadays. Some data are available, but the images are very volumetric and the memory is very high. So for the processing, it takes time, and uh, speed of the computer is needed. Then different scattering, that is surface scattering, volumetric scattering. So if it is incident and this, then back scatter in the upper area, then it is surface scattering. Oh, and second thing is, it is if it is painted through the canopy cover, then the middle of the trees, then it's scattered in different ways. In the 360 ways it's scattered, so that is called the volumetric scattering. So scattering in different ways is called the volumetric scattering due to the different shape and different position of the trees. Then it is the surface and volumetric scattering, both of these are present in lower part of the trees. So these three type of scatterings are maximum time we just calculate and just give information about all the physiography of these trees. So these are the example of different bands already covered, and in the passive microwave remote sensing, some applications are like soil moisture estimation, snow water equivalent, sea lake ice extent, sea surface temperature, atmospheric water vapor, surface wind speed, cloud liquid water, rainfall rate. So these are the application of passive remote sensing. And overall, the different applications are soil moisture estimation, crop identification, snow studies, flood mapping, geology, forestry, urban land use, hydrocarbons, then sea state measurement and ocean circulation, oil pollution, that is oil spill, then geophysical parameters, ocean geoid studies, and Indian monsoon studies, monsoon temperature profile, atmospheric minor constituents. So lot of applications are there as it measures the different height informations and depth related informations are there in the ocean areas. So it give the different information which is not available for the optical remote sensing. So after that, we'll discuss some of the multiple questions based on the hyperspectral, thermal, and microwave remote sensing. So synthetic aperture radar is one of the example of which remote sensing. So generally, synthetic aperture radar is
Active.
active remote sensing. Then, who is the example of image processing system? Uh, ADAS Imagine NV PCI Geomatica. So, image processing can be conducted in all these softwares like ADAS Imagine and NV and PCI Geomatica. So, the answer is all of the above. Then airborne visible infrared image spectrometer, previously also discussed. This is average data is developed by ITARS Research and Jet Propulsion, JAXA and Roscosmos. So it is Jet Propulsion
Yes.
Lab of the NASA. Then thermal sensor generally sense radiate energy from target heat through. So what is the answer? Radiation, convection, conduction, all of the above. So the answer is all of the above. Radiation, convection, and conduction, all these are thermal related features are there. Then sonar image is an example of dash form of remote sensing. So this is the example, and this is the image present in the sonar area. So basically use this sonar technology in the ocean areas, and sonar sensors are there in the different ships. So it is active or passive? It is an active imaging system because it create its own source of target and then reflected back. So after that, it creates ultrasound pulse and then it receive this ultrasound pulse. So time difference is calculated. Then it measures the different height information of this height and depth information of this ocean. So generally, why we call the synthetic aperture radar? What is the synthetic aperture? So because the antenna is very small in the um, sensor in the satellite image. So it is virtual antenna. It create a virtual antenna. So large level of antenna are created in the virtually, so that the larger coverage of this area to be detected. So if it sends some signal, then it needs a larger antenna so that it receive all this information in the larger way. So it is a virtual technology so that it receive all these different areas impulse and different reflected radiations. So this that is the cause that this aperture is called the synthetic aperture. It's a simple diagram. So it combines all these pulses and then form a larger synthetic antenna for higher resolutions. So these are the some virtual larger antenna in the sensor which is mounted in the satellite. So this receive all these backscatter informations. After that, they synthesize all this information, then create some image. Then thermal remote sensing primarily detects reflected sunlight, emitted electromagnetic radiations, backscatter microwave signals, and reflected light waves. So generally, thermal remote sensing is emitted electromagnetic radiations. So it is not reflected, only emitted. So these emitting informations are gathering in the form of the thermal informations. The typical wavelength range used in the thermal remote sensing is, so it is also copper, that is 3 to 14 micrometer. Which satellite sensor is known for the thermal infrared imaging? So the answer is A, that is a Landsat TM. TM means thematic mapper and enhanced thematic mapper bands. Then thermal remote sensing is most commonly used for, so it is used for measuring land surface temperature. So this is the one of the hyperspectral satellite image. Which best describe the hyperspectral remote sensing? So capture image in red, green, blue bands only? No. So it is not only red, blue, green
See,
bands.
See, sir. See.
Capturing image in many narrow bands, continuous and spectral bands. So it is C. Hyperspectral sensors typically record how many spectral bands? It is more than 100 bands.
More than 100 bands.
Which of the following is a spaceborne hyperspectral mission? So Modi's is a hyperspectral, Sentinel, Landsat. So Hyperion is a one of the hyperspectral image. Then hyperspectral data are specially used for uh, regionally used for mineral identification and vegetation. Then which of the following is the advantage of microwave remote sensing compared to optical remote sensing? So now we just cover this. So it requires sunlight for illumination? No. Cannot penetrate cloud? No. Can operate day and light in all weather system. So C is the correct answer. It can operate in day and light in all weather system and it can penetrate through cloud. Then in active remote sensing, the sensors detect naturally emitted microwave radiation from Earth or emits its own microwave signal and measure the backscatter. So B is the correct answer. So its own microwave signal are emits and measure the backscatter. Which frequency band is microwave remote sensing is the shortest wavelength? So these are the wavelength L, X, KU, K, all these bands are there. So X is the shortest because this is the band and this is the wavelength in centimeters. So X is the 2.4 to 3.8. Then C is greater than X, S, L, P, all are greater than X. Only K and KU and KA are smaller than X. That's why X is the smallest. L, C, P are largest. The main reason for using synthetic aperture radar in microwave remote sensing is to capture image in color? No. To increase spatial resolution by synthesizing a larger antenna? Yes. To increase spatial resolution by synthesizing a larger antenna. So it virtually synthesizes the larger antenna to increase the spatial resolution. So it measures only atmosphere gas. It is not corrected. It reduces the need for data processing. Not corrected. Then passive microwave remote sensing is primarily used for measuring the land surface temperature and soil moisture. So this is the answer. So previously was also discussed this. Then in optical remote sensing, optical means in blue, green, red, infrared region. What is the primary source of illumination? So primary source is the sunlight. So in optical means we use the sunlight data, sunlight information. So sunlight reflected back to sensor, then this reflected back information are created some image. So which atmospheric factor has the most significant effect on the optical remote sensing data quality? Which atmospheric factor has the most significant effect? So mostly humidity is not affected by the optical remote sensing. Wind speed is not affected after a particular height. Magnetic field is not affected so much to the optical remote sensing. So the answer is cloud. So in the optical sensor, if the cloud is there, so there is no surface features are getting information of that areas behind this cloud area. So cloud cover to be avoided in the optical remote sensing, but in microwave there is no cloud cover is present because it penetrating through the cloud cover. So it is a all weather satellite. So we'll cover all this related to the microwave remote sensing. So if you need any further clarification in VV polarization, SB polarization, then we'll take some 10 to 15-minute class next tomorrow, or otherwise other topics to be covered. So what's your suggestion? Okay, then if any doubt is there, then just ask me, or we will after that uh, conclude this session. Okay, Vinay, just ask.
सर वो परसों वाले लेक्चर के लिए था मेरा क्वेश्चन,
हाँ
जो आपने मल्टी स्पेक्ट्रल और हाइपर स्पेक्ट्रल उसके लिए, तो मैंने जैसे थोड़ा सर्च किया था और सर डेटा डाउनलोड किया मैंने हाइपर स्पेक्ट्रल का, बट उसका इमेज रिजोल्यूशन तो बहुत ही कम था। मतलब
हाँ, देखिए अभी जो मैंने बोला ना एवरेज डाटा जो, हाँ
हाँ
अब
सर,
उसके 30 आई थिंक 30 मीटर रिजोल्यूशन होगा।
हाँ मतलब शायद 2-3 स्टेट एक ही उसमें आ गए थे।
हाँ तो
2-3 सॉरी
आई थिंक वो हाई सी डाटा होगा, और हाइपेरियन इज नॉट अवेलेबल आई थिंक, बट हाई सी इज अवेलेबल। तो हाँ, अभी जो हाइपरस्पेक्ट्रल रिमोट सेंसिंग है, हाइपरस्पेक्ट्रल डाटा बहुत कॉस्टली है, इमेज है, तो वो अभी फ्रीली अवेलेबल नहीं है। जो लो रिजोल्यूशन अवेलेबल डाटा है वो उसको फ्रीली अवेलेबल है, जस्ट फॉर रिसोर्स पर्पज। फॉर पर्टिकुलर प्रोजेक्ट और पर्टिकुलर एरिया, हाइपेरियन, हाइपेरियन ऑल्सो लो रिजोल्यूशन, इट इज ऑल्सो, इसको भी हम मिनरल के लिए कर सकते हैं, लेकिन हाई रिजोल्यूशन डाटा अभी तक तो फ्रीली अवेलेबल नहीं है। कमर्शियली अवेलेबल है एवरेज डाटा, जो कि 2 से 5 मीटर रिजोल्यूशन देता है, बट इट इज़ वेरी कॉस्टली और इज़ नॉट अवेलेबल टू ग्लोबली। अगर नेक्स्ट कभी मतलब अपडेट होता है तो देखेंगे, क्योंकि हाइपरस्पेक्ट्रल नाउअडेज वेरी डिमांडिंग सेंसर, अभी उसका यूज़ बहुत ज़्यादा है अभी स्पेसिस आइडेंटिफिकेशन के लिए। अभी तक तो नहीं हुआ है, अगर देखते हैं अगर नेक्स्ट कुछ होता है तो अपडेट। बट उसमें कितना बैंड्स था?
सर आई थिंक 200 प्लस थे, वो फाइल रखी है मेरे पास।
तो इसका शायद हाईसी डाटा होगा। हाँ,
एक सेकंड
हाईसी।
सर। इसमें सर हाँ 249 दिख रहे हैं, मतलब कुछ टेक्स्ट फाइल होगी तो 240 प्लस मान लीजिए।
हाँ, उसका हाईसी डाटा ही होगा मुझे लगता है। बहुत
तो
लो
सर
रिजोल्यूशन है उसमें। एक्चुअली क्या है
हाँ
कि जनरली क्या है कि हाइपरस्पेक्ट्रल इमेज को हम फीचर आइडेंटिफाई के लिए यूज नहीं करते। उसमें लार्जर मिनरल एरियाज, रॉक आइडेंटिफिकेशन, उसको आइडेंटिफाई करने के लिए यूज करते हैं। उसको हम इमेज को इंटरप्रिटेशन जनरली नहीं करते। उसमें जो ग्राफ क्रिएट होता है ना, जो उसका जो आप अगर क्लिक करेंगे तो एक ग्राफ क्रिएट होता है, जो यूनिक ग्राफ। तो वो ग्राफ आइडेंटिफाई करता है कि इस एरिया में कौन सा मिनरल है। वो मिनरल का जो ग्राफ आता है उसको हम, जो स्पेक्ट्रल लाइब्रेरी एक होता है, उस जो सॉफ्टवेयर है एनवी में है, डिफरेंट डिफरेंट सॉफ्टवेयर में है। तो उस स्पेक्ट्रल लाइब्रेरी से सिंक्रोनाइज करने के बाद हम कंफर्म हो जाते हैं कि इस एरिया में हेमाटाइट है, मैग्नेटाइट है, जियोलाइट है, इस टाइप का मिनरल्स है। So basically, your graph-based informations are there, not image-based information. इमेज में हम इतना आइडेंटिफाई नहीं कर पाएंगे, इसलिए वो लो रेजोल्यूशन दिखा रहा है। और बोथ इमेज आइडेंटिफिकेशन एंड ग्राफ बेस्ड इंफॉर्मेशन के लिए एवरेज डाटा यूज करते हैं, तो वो तो अवेलेबल नहीं है अभी। जो भी है अभी उसको देखना पड़ेगा। देन
तो
नेक्स्ट।
सर एनपी भी पेड, मतलब आपने बताया
हाँ,
कि
एनवी, हाँ,
जिसका
एनवी तो पेड
लाइब्रेरी
है।
है।
और एक
हम्म,
यूरोपियन जो स्नैप बोला ना, वो फ्री ऑफ कॉस्ट है। स्नैप का जो सॉफ्टवेयर है स्पेसिफिकली
ओके सर।
माइक्रोवेव के लिए। और एक साक अहमदाबाद का है, वो उसका एक टूल था। अभी अगर मेरे पास है तो मैं कल देखता हूँ, नहीं तो कल वो जो सॉफ्टवेयर है वो चैट में भेज दूंगा। बहुत ज़्यादा मेमोरी का नहीं है, अगर मिलता है तो मैं भेज दूंगा।
जी सर,
ओके,
थैंक यू।
थैंक यू। ओके, देन भावना राजपूत is present not?
Yes, sir.
Okay, then आपका कुछ डाउट है?
नो सर। सर एक बात पूछनी थी, ये प्रैक्टिकल क्लासेस कब से लगेंगी?
अभी तक तो प्रैक्टिकल का दिया नहीं है, लेकिन अ, अगर होता है तो मैं लास्ट क्लास में थोड़ा सा प्रैक्टिकल दिखा दूंगा, लेकिन स्पेसिफिक प्रैक्टिकल बेस्ड क्लास अभी तक मुझे इन्फॉर्मेशन नहीं आया है। अगर आता है तो मैं कम्युनिकेट करता हूँ, मैं पूछ भी
और
लेता हूँ।
साथ सर सिलेबस प्रैक्टिकल का?
प्रैक्टिकल का सिलेबस आपके जो ऑनलाइन में नहीं है? ऑनलाइन जो सिलेबस है उसमें नहीं है?
अभी
देख
चेक
लीजिए एक बार।
कीजिएगा।
हाँ, वो उसको चेक कर दीजिए। प्रैक्टिकल का भी बुक है स्पेशली। और जो भी
सर
एक्चुअली,
वैसे
हाँ,
सर वो ऑनलाइन नहीं है, मैंने ई कंटेंट और ई ज्ञान कोश दोनों पे देखा था।
अच्छा अच्छा, एक काम कीजिए,
वो
एक बार एक जो रीजनल सेंटर है आपका जो, और एक दिल्ली
सर
का जो मेल आईडी है, उसमें जितना भी आपको मतलब जो सिलेबस नहीं आया है पीडीएफ में और कुछ प्रॉब्लम है, उनको मेल भेज दीजिए। उसके बाद अगर रिप्लाई कुछ आता है तो हम देखेंगे, नहीं तो मैं मेरे तरफ से मैं भी पूछ लेता हूँ कि प्रॉब्लम क्या है। अगर सिलेबस प्रेजेंट होगा रीजनल सेंटर में तो आई विल प्रोवाइड इट।
सर जैसे
तो ये
लास्ट
आप
सेम
जो
में
बोल रहे
हमको
हैं अभी, ये फर्स्ट
फ्राइडे,
सेमेस्टर का है या सेकंड, सॉरी, फर्स्ट का ना?
ये सर सेकंड सेम का है,
ये सेकंड का है।
008।
008 का प्रैक्टिकल?
हाँ सर, वो फर्स्ट सेम में भी हमें ड्राइव के थ्रू ही शेयर किया गया था प्रैक्टिकल का, मतलब उन्होंने एक्सरसाइज वाइज डिवाइड करके अलग अलग पीडीएफ बना रखी थी।
अच्छा, फर्स्ट
तो
सेमेस्टर का प्रैक्टिकल हुआ था?
हाँ सर, हो गया।
अच्छा, तो देखते हैं अभी, शायद थ्योरी खत्म होने के बाद प्रैक्टिकल स्टार्ट होगा। अगर लेट भी होता है तो आप उस उनको थोड़ा मेल भी भेज दीजिए, तो उनको भी पता चलेगा कि, तो इसमें ज़्यादा डिले करना ठीक नहीं है, क्योंकि उनका लॉट ऑफ कोर्स होता है, तो शायद कुछ छूट गया होगा।
ठीक है सर।
ठीक है, मैं इसको भी देखता हूँ, अगर मुझे अवेलेबल होगा तो मैं सेंड कर दूंगा थ्रू दिस चैट।
ठीक है
ओके
सर।
ओके ओके भावना,
थैंक यू सर।
थैंक यू। ओके, गुड नाइट।
Thank you, sir.